Arson scenes obviously are where forensics really is going to come into play with a lot of the fires and explosions. So what do we see at an arson scene? They're often very complex to interpret. There's a lot of things happening. Certainly what makes arson a little bit different is that it's planned. So there's been forethought about leaving no evidence. So it's generally people aren't, most arsons occur with planning, and there's not going to be a lot of evidence left behind. It's very common that the perpetuator, the suspect, is not going to be present during the fire. So they're going to start the fire and leave, therefore they're not on scene to be visible. And of course, the fire destroys any of the evidence that was left behind. So we have a lot of complications to this. Also, the physical scenes can be pretty complex to interpret. So what we are looking for is we're going to be identifying relevant chemical materials from the scene. We often call them accelerants, right? So we're looking for things that suggest that there was an arson, mostly accelerants like gasoline and lighter fluid and propane. We're going to also reconstruct and identify how the fire started. Where did it ignite and where did it travel to? So the path of the fire will help us get to the origin site so that we can determine whether that fire was started intentionally or not. And this really requires an awful lot of experience. So even if you took courses in this, it doesn't compare to being an arson investigator who's been doing this in the field for 15, 20 years. The amount of experience of just having intuitive sense of having seen things and know what's normal and what's not is really important in this field. So the arson investigator is going to begin looking, as soon as the fire has been extinguished, they're going to begin on site. Obviously safety first, the fire has to be controlled. So key idea is we're trying to minimize the loss of evidence. So we're looking for making sure that anything that might deteriorate over time that we can collect and preserve. It's always one of our main goals. Also, and of particular importance is the accelerant. So if the arson was started with an accelerant, so with some kind of fuel source, some liquid fuel source, they evaporate very easily and they will disappear. So we need to try to put things in very airtight containers to hold, if there are any traces of accelerant, that we can find them when they get to the lab. So that is we're looking for the origin site, and we're looking for accelerants or ignition devices. Those are going to be our main piece of evidences. Can I find accelerant, traces of accelerant? Can I find igniter? What started the fire? And that's all going to be found at the origin, and the origin is going to tell me a little bit about how the fire proceeded. So what would I see at an arson scene that might tell me it's arson as opposed to just a random fire? Evidence of separate and unconnected fires, right? So one fire will tend to start another fire, so there'd be a trail. But if I have two separate fires, that suggests that the two fires were started independently. Use of streamers to spread the fire from one area to another. So whether it's a trail of accelerant or whether it's like, things that will catch on fire putting away. Kind of like the idea of having Kindle is I want to have something that's going to, lead the fire to where I want it to go. An irregularly shaped pattern on the floor resulting from pouring accelerant onto the surface. So I might see where the accelerant was on the floor, I might see a more intense charring or some kind of different pattern. And also severe burning. So the accelerant will burn at a very high temperature, and that indicates, so if I see an area where it's particularly heavily charred or it looks like it was a hotter temperature, it suggests that there might have been an accelerant. Also, looking for some kind of igniter. So a match would be most common, burning cigarette, firearms, ammunition, a match striker, or those electrical sparking devices, the butane lighters, a Molotov cocktail, something like that suggests that this was the spark, this was the activation energy that began the reaction. Of course, if it's a match, now we have to determine, was that left intentionally or was that just an accidental drop of a match? Flashover is an important thing that we can see. And this occurs when all combustible fuel, so when all of the liquids that are combustible reach the ignition temperature and simultaneously ignite to engulf the entire structure. So it's kind of like the big boom of a fire. It can cause the fire to spread to distant area from the origin, so I can get that illusion of two separate fires because it jumped, because all of a sudden all of that fuel started to catch on fire in the air and it kind of like jumps to another area. So separate fires doesn't mean it has to be arson. Also, we get irregular patterns in these post-flashover conditions, so I can have, if the accelerant that was suspected for it, I have to really find these accelerants. So I might get flashover can cause something to look like arson when in fact it's not. It's just a regular product of the fire pattern. So I have to be looking for things that might indicate. So things that might be different to my normal burn pattern might be a deep depth of char, like an area that's particularly thick, and the char, that blackening is really sort of set deep into the surface. V-shaped burn patterns going up the wall also. And a very low intense burn area. So where I'd see like, I don't see it going way up into the wall, but I see an area where it didn't get tall, but it was very intense. Those are suggestive of arson versus flashover. But I have to be very careful that the only way to really tell whether it was arson versus flashover might be if I find that accelerant. When we go collecting fire evidence, because we're looking for these traces of accelerant and we're looking for these igniters, we want to think about where we can begin. We want to begin with the origin of the fire. So at the suspected origin of the fire, we're going to get the ash, soot, and any porous materials. We're going to collect samples of the debris left behind, storing it in an airtight container. Generally, it looks like an empty paint can where you put the top on, except that paint was never in it. It was designed for collection of evidence and it's brand new. Wide mouth glass jars with the top on can also work. You do need to leave a little airspace because otherwise the pressure can build up and they might pop. So you can't fill them all the way to the top. There needs to be left what we call the headspace. Also, you never want to use plastic to store fire scene evidence. Plastics can melt from the presence of the accelerant, and so you can destroy your evidence accidentally. Also, you want to make sure you have a sufficient amount of substrate. That's like a sampling of similar but uncontaminated control sets. So if you had two different areas of burn, one where the origin site is and one later on in another area that was also burned, so you'd have a comparison of the site of origin to another site to say, yes, there's a difference. This is particularly important for things like carpet. Carpet has certain chemicals in it, so I need an area where I thought it was started and an area where it wasn't started to have the background petrochemical residues that aren't due to gasoline or accelerants. I also am looking for, I could find, there are devices called sniffers, or a trained dog can be looking for those scents of the accelerant. They can be very helpful in sort of tracking down the site of origin or where I might find evidence. Once I get to the lab, then I need to take this material and recover it. This wouldn't be something that a scene investigator does. But there's two different techniques that are used. One is to take the headspace. So remember, those accelerants are going to continue to evaporate, but inside the can. So that top air space of the can will have a lot of the accelerant vapors in it. And so you can remove them with a syringe. So they literally put a syringe through the top of that paint can and try to extract out some of that gas. And then they can use a gas chromatograph to look for what's in that airspace. Another thing they can do is what they call the vapor concentration technique. They can put a piece of charcoal strip inside the airtight debris container, and it will absorb a lot of those gases, and it sort of concentrates that. Instead of being just in the air, it's sort of concentrated onto that charcoal strip. Then they can take that, wash it with a solvent, and do gas chromatograph on that solvent recovered from there. And sometimes that improves the signal. So we talk about the headspace testing and vapor concentration. This is an example of the vapor concentration method. So here would be the charcoal strip that absorbs all the materials, then is then taken out, washed in solvent, and run through a gas chromatogram.